In this class, let us study about different types of quadrilaterals. We know that a quadrilateral is a four-sided polygon. And what else do we know about a quadrilateral? The sum of the interior angles of a quadrilateral will always be equal to 360 degrees. Now, the classification of a quadrilateral is mainly based on the difference in the properties of three things. First, its sides, then its angles, and then its diagonals. Now, based on the differences between these three things, we can classify the quadrilateral in many ways. Here we are learning 6 main kinds. Now we will start with a basic kind of quadrilateral, which is called a trapezium. Now, a trapezium is a quadrilateral whose one pair of opposite sides are parallel. So, how will that look like? This is how parallel lines look like, right? So, draw two parallel lines and join them. You have a trapezium. Let us name it A, B, C, D. Now, what are parallel lines? Any two lines are said to be parallel if however much you extend them, they will never meet. Also, the distance between the two parallel lines will always be equal. Look at this. Or in other words, the parallel lines will always be equidistant. You take this distance or this distance or this distance, it will always be same. Now, look at the other two sides, AD and BC. They are looking like this, which means they are not intersecting now. But then keep on extending them like this. If you keep on extending them, at some point they will meet. That means they are not parallel. Also, did you notice the distance between them? The distance is not same. See how much it is in this part? So they are not equidistant. The distance between them will not be equal. So this is how a trapezium looks like. Two opposite sides will be parallel and the other side need not be parallel. And what is the other thing that you know about parallel lines? If you have two parallel lines and a third line which cuts them like this, which by the way is called a transversal, we have done a video on that, please check it out. So if a third line, the transversal, cuts them like this, the two parallel lines, then the angles on the same side of the transversal will be supplementary. That means their sum will be 180. Or in other words, if you take this angle to be x degrees, then this angle should be 180 minus x. Because 180 minus x and then plus x, it gets cancelled and you will get 180. So, if you have two parallel lines then and a transversal cuts them, then the angles on the same side of the transversal will be supplementary. And the second thing you know about parallel lines is that if you have alternate interior angles, see the transversal, one angle to this side in this vertex and another angle in this vertex to this side, they both will be equal. If this is x, then this will also be x. That means if you have a Z-like figure, these two angles will be same and these two angles will be supplementary. So that is the property of the angle of a trapezium. What is that? See the two parallel lines, AB parallel to CD. This is the sign of parallel lines. So these two are parallel. Consider AD to be the transversal which cuts them. That means if this is x, this will be 180 minus x. Similarly, now consider AB and CD both parallel lines and consider BC to be the transversal which cuts them. That means if this is y, this will be 180 minus y. So that is the property of the angles of a trapezium. It is that the adjacent angles between the parallel lines are supplementary. Notice the important thing, it is between the two parallel sides, but between the two non-parallel sides they are not adjacent. There is no guarantee that if you add x and y you will get 180. There is no guarantee that you add these two and then you will get 180. There is no guarantee on that. It is only the adjacent angles between the two parallel sides. And this brings us to the third thing, which is the diagonals. The property of the diagonals is that the diagonals will intersect proportionally. And how will that look like? There you have one diagonal, there you have another diagonal, their meeting point O, and now what we know about the diagonals is that they intersect proportionally. And what does that mean? That means that AO by OC will be equal to BO by OD. And let me take an example and tell you. Suppose the ratio is 2 by 3. That means if you divide AO by OC or BO by OD, you should get 2 by 3. This isn't just an example. Let me show you how that works out. Suppose AO is 4, then how much will OC be? See, AO by OC is equal to 2 by 3, but AO is what? It is 4. That means OC is equal to cross multiply. 4 into 3 is 12. 12 divided by 2 is 6. That makes sense, right? OC is 6. So what do you have? AO by OC will be 4 by 6, which will be 3 by 2. Also, suppose this is 10. BO is 10. Then can you tell me what will be OD? What is that number which when multiplied by 2 gives 10? And the same number you have to multiply by 3 and write here. What is that number which when multiplied by 2 gives 10? So 5. So you can put 5 here also. It is 15. So the diagonals intersect proportionally. That is the property of the diagonals of a trapezium. Now we go on to the next kind. Before that, I would like to add something. The area of a trapezium, it's not important, but I would still like to mention that the area of a trapezium is half the sum of parallel lines or parallel sides into its height. Let us see how to define that. Is the height of the trapezium, and remember these two are two parallel lines, which means you take the distance here or at this place or at this place, it does not matter. I have just drawn it here for convenience. So this is the height, and also you see the parallel sides, they are known as the bases of the trapezium. So the area is the sum of the parallel sides. Remember, not the non-parallel sides but the parallel sides. See the two parallel sides? So the area is half of sum of parallel sides is 10 plus 15 would be 25, that into the height. The height is 4. So that means cut, it is 50, and always remember the unit of the area will always be square units. It will be centimeter square, meter square, things like that. So this is how you find the area of the trapezium. It's not needed here, but I just thought I will mention it here. Now let us go on to the next type of the quadrilateral, which is called a parallelogram. Before that, let me tell you one thing. What we are going to see here is a different type of quadrilateral. Now, I think I have mentioned this earlier. Think of a fruit. You know what all conditions a fruit has to satisfy? Now think of an orange. So, the orange is a type of fruit, which means the orange will satisfy all the conditions of a fruit. It will have a seed in it, or what all conditions the fruit satisfies, the orange will also satisfy that. So that means every orange will be a fruit, but every fruit will not be an orange. Similarly, take a kind of orange, like for example, a clementine orange or a mandarin orange. Then what do you have? Suppose you have a clementine orange here. Then this is a special kind of orange, which means the clementine orange will satisfy all the conditions of an orange, but the orange will not satisfy all the conditions. Why? It can be a mandarin orange, and fruit will not satisfy all the conditions of an orange. It can be a banana or an apple. So here with the quadrilateral also we are going to see the same thing. Trapezium is a basic kind. It is like a fruit. Now we are going to study about something called a parallelogram, which will satisfy all the conditions of trapezium, but it will have some extra conditions of its own, okay, of its own. So that we will see. The next is called a parallelogram. So how does the parallelogram differ? As I said, it satisfies all the conditions of a trapezium and a few of its own. We will see where it differs. Next we will study about a parallelogram. What was a trapezium? Two parallel sides, and the second pair of sides need not be parallel, right? So that is where the trapezium differs. In it, both the pairs of opposite sides have to be parallel. That means this thing not going to happen. You need the other side also to be parallel. That means this thing is not going to happen. You have to draw again a parallel side like this. See? So this is how your parallelogram will look like. My drawing is really bad. I will draw it once again. I hope you understood what I was saying. There. A, B, C, D. In trapezium, just one pair of opposite sides had to be parallel. But in parallelogram, both the pairs of opposite sides have to be parallel, and they have to be equal as well. You see what is happening here? It is satisfying all the conditions of trapezium, plus it means that these two are, AB is parallel to CD and BC is also parallel to AD. Now the sign for being parallel is this. These two are parallel and these two are parallel, and the opposite sides are equal as well. Now this brings us to the angle part. What did we learn about the trapezium? Whenever the two sides are parallel, we learned that the adjacent sides are supplementary, right? But then here what do you have? These two sides are also parallel. That means these two sides, consider AD and BC, okay? And AB be the transversal which cuts them. Two parallel lines, a transversal which cuts them. That means these two added should give you 180. Again, consider two parallel lines and a transversal BC which cuts them. That means this angle and this angle should be supplementary. So you see what has happened here? There in the trapezium, what did you study? You studied that the adjacent angles between parallel sides. But here there is no such thing. These two are parallel and these two are parallel. That means all adjacent angles are supplementary, not just the ones between one pair. All adjacent angles are supplementary. Then, did you notice one thing? Look at the opposite angles, x and x. That means x and x are equal. 180 minus x, 180 minus x, which means opposite angles are equal. So what do you have here? You have that the adjacent angles are supplementary and the opposite angles are equal. Then what about the diagonals? They intersect proportionally in a trapezium. But what happens here? That proportion is actually 1:1. What do you mean by two things? Their ratio is 1:1. That means they are equal to each other. X is equal to y. So that is what you have here. They bisect each other. So what we have here is, suppose AC is equal to 10 centimeter. Now the diagonals bisect means what? Anything by is 2. That means it cuts it into two equal parts. So this point O cuts AC into two equal parts. That means AO will be 5 and OC will be 5, or in other words, half of AC is equal to OA is equal to OC. Similarly, look at this. Suppose BD is say 11 centimeters. Then what happens? This again cuts it into two equal parts. So one side will be 5.5 and this side will be 5.5, or in other words, BD by 2 is equal to OB is equal to OD. That is what we mean by they bisect each other. They cut each other into two equal parts. So you see how from trapezium we came to a parallelogram. In a trapezium, only one pair of opposite sides was parallel. But when we came to a parallelogram, we saw that both the pairs were parallel to each other. Not only that, they are equal. The opposite sides are equal to each other. And the angles, we saw that the adjacent angles are supplementary, which means any two sides you take, they will add up to 180. And the diagonals, they bisect each other. Now let me ask you one question. Look at the properties of the angles, and if I give you just one angle, can you tell me the other angles? Just one angle, I will tell you. What about this angle is say 80. Can you find all the other angles? Opposite angles are equal, which means if this is B, this is also, if this is 180, sorry, if this is 80, this is also 80. And any two adjacent sides are supplementary. Add any two, you should get 180. So 100 here, add 180, here 180. Again, see. So that is what happens. This is how this rule helps us. Just knowing one angle of a parallelogram is enough. You can find out all the others. Now we come to a different kind of a parallelogram, which is called a rectangle. And how does that change? Again, you remember what I told you about fruits and oranges? Again, the parallelogram, the rectangle will satisfy all these conditions that a parallelogram satisfies, plus it will have some extra conditions. And what is that extra conditions? Let us see. There you have a parallelogram, and we will make this parallelogram into a rectangle, just like we made the trapezium into a parallelogram, right? So we will make this into a rectangle. We are now studying about the third type, which is a rectangle. So the properties of the sides of the rectangle is the same as the parallelogram. Nothing more to add. The opposite sides are parallel and equal, which means if AB is 4, CD will also be equal to 4. If BC is say 7, then AD will also be equal to 7. The opposite sides will be equal and parallel. So that nothing different about it. But then this is where it changes. All the angles of a rectangle have to be 90 degrees. So you see the difference here. In the parallelogram, all you had to do was both of them should add up to 100. Does not matter in what way. It can be 80 and 100, or it can be 40 and 140, whatever way. But it just had to add up to 180. But then in a rectangle it is more specific. Each angle has to be 90 degrees. Or you can just say one angle is 90 degrees. With that would mean all the other angles are 90. Why is that? Suppose this one angle is 90. I am rubbing this because this sort of a thing will never be 90. 90 is always looks like L. So I have to rub this side and draw it like this. But then if this is 90, these two angles are supplementary. That means this should be 180 minus 90. So this should also be a sharp end. Right? Similarly, this should also be a sharp end. Why is that? Any two adjacent angles are 180. So therefore, this should also be 90. And that means this should also be 90. Because any two sides added should give 180. So if one is 90 degrees, then all the others have to be 90. That is the property of the angles of the rectangle. They all have to be 90 degrees. And what about their diagonals? Their diagonals have one extra quality. They bisect each other. That is true. But then they also have to be equal. That means AC is equal to BD. We already have from the sides that the opposite sides are equal. That means, say if this is 8, this will also be 8. If this is 4, then this will also be 4. And what they are saying is that the diagonals will also be equal. If AC, you consider AC and BD, they both will be equal. So suppose if they meet at a point O. Remember, rectangle is a parallelogram. So we already have AO is equal to OC and BO is equal to OD because they bisect each other. That means this point cuts AC into two equal parts, cuts BD into two equal parts. So now what extra thing we have here with the rectangles is that all of this is equal. AO is equal to OC is equal to OD is equal to OB. All of that are equal. Now we will see how this works out. Suppose you have a rectangle, okay, and its sides are given, and its sides are given as say 8 and say 10. Then what is its diagonal? Can you find out? Is there any way to find out? See the angle. The angle here is 90 degrees, which means you can apply the Pythagoras theorem. What is that? Look at the 90 degrees. Whenever you have a 90 degrees, that will be the largest angle of that triangle. And the side opposite to the largest angle will always be the largest side. Or in other words, hypotenuse will always be the largest side of a right angled triangle. And AC square is equal to AD square plus DC square. But AD is 8 square and this is 10 square. So this would be 64 and this would be 100, and together there will be 164. So AC square is 164, which means AC is equal to 164 square root of 4 into 41, which is equal to 2 root 41. So that is this is how you find the hypotenuse. This is how you find the hypotenuse of the rectangle. So this was what we studied about the rectangle. The properties of its sides, that its opposite sides are equal and parallel, its angles are all 90 degrees, and the diagonals bisect each other and are equal. Now this brings us to the fourth type of quadrilateral, which is called a square. And as with all the other previous cases, The square will satisfy all the conditions of the trapezium, of the parallelogram, of the rectangle. But then it does not happen the other way. The trapezium the trapezium is not a parallelogram. A parallelogram is not a rectangle. But it works the other way around. Square is all of that. Square is a trapezium, square is a parallelogram, and it is a rectangle. So these were the properties of the rectangle. The square satisfies all of them. Angles, there is nothing more to add. All the angles are 90, so it has nothing more. But then the difference comes with the sides. The square, in a square, this would be a rectangle, right? In a square, all sides are equal. That means, you see the rectangle here? This part is not going to work. It has to stop here. Its adjacent sides have to be equal. So this is how from a rectangle you get a square. So you see how we started from a trapezium and we have come to a square. So this is what happens to a square. All of its sides are equal. All of its angles are equal, and its diagonals also have one extra condition. These are the conditions of a rectangle, right? The square satisfies all of them. Plus it has one extra condition. Can you guess what it is? Already you have that the diagonals are equal, which means AC will be equal to BD, and they bisect each other, which means AO is equal to OC is equal to BO is equal to OD. Right? To the square we have one more condition. That condition is that it bisects perpendicularly. What does that mean? That means at the place where it intersects at right angles. So how does this help us? Suppose I have a diagonal, okay? Suppose the diagonal of a square is say 8. With that, can you find its find its side? Let us see how to find it. Consider the smallest triangle AOB. If this is the right angle, then what is the hypotenuse? Hypotenuse is the side opposite to the right angle, which means AB. So applying the Pythagoras theorem, AB square is equal to OA square plus OB square. But then, do you know what OA or OB is? But what do you know? You know what is the whole of AC. The whole of AC is 8. That means half of AC is equal to 4. But what is half of AC? It is AO. So that means AO is 4. So AO square is 4 square. What about OB square? If AC is 8, look at the diagonals. Both the diagonals are equal, which means BD is also equal to 8, which means half of BD is equal to 4. But what is half of BD? It is BO. So this is also equal to 4 square. So 4 square is 16. 16 plus 16 is 32. Now AB is the square root of 32, which means square root of 4 into 4 into 2, which means 4 into square root of 2. This is the side. 4 root 2. That means all the sides are 4 root 2. So this is what a square is, and this is the properties of a square. So how will you define a square? Square is any quadrilateral whose all sides are equal and whose all angles are equal and whose diagonals bisect each other perpendicularly and are equal. So this brings us to rhombus. Now we come to a quadrilateral called rhombus. So now you would see that I have rubbed off all the details we wrote about parallelogram and rectangle and square, because this is a slightly different quadrilateral. Look at its conditions. Its sides have to be equal. Its angles Its opposite angles equal, adjacent angles supplementary, which means what? Which means that rhombus is a parallelogram, correct? So this is how your rhombus looks like. Okay. Its all sides are equal. AB is equal to BC is equal to CD, and its opposite angles are equal. This angle is equal to this angle. A is equal to C, D is equal to B. So why is it a parallelogram? You remember what we said about the parallelogram? Exactly this condition. Its angles, a parallelogram's angles satisfy exactly this condition. Opposite angles equal, adjacent angles supplementary. So this condition is the same. Look at the sides. For a parallelogram, it is enough if the opposite sides are equal. All the four doesn't have to be equal. Just the opposite pairs have to be equal. So that means rhombus actually satisfies more conditions. So that is one difference. And what is the second difference? See here, a parallelogram does just this. The diagonals of a parallelogram are what? They just bisect each other. There is nothing more. At whatever angle it may be. One angle must be 60 and the other must be 120. It does not need to be perpendicular. Perpendicular means 90 degrees. It does not need to be 90 degrees. The parallelogram, it just has to bisect in any angle, whatever. But then in a rhombus, that doesn't happen. It has to be 90 degrees, which means one more extra condition. So, rhombus is a parallelogram whose diagonals bisect perpendicularly, or in other words, they are 90 degrees. And another important condition, whose all sides are equal. And all sides are equal. Now, what about a square? Square also has all sides equal. So how does rhombus and square connect to each other? Is rhombus a square or square a rhombus? So we have to see which one satisfies more condition. So see this, that part is equal. Square also has equal sides. Rhombus also has equal sides. But this angles part is where the problem comes. See the rhombus? Just the opposite sides have to be equal. They don't have to be 90 each. They can be 20 and 160, 80 and 100. They can be whatever. But then the square has an extra condition that 20 and 160 is not going to work. Everything has to be 90 degrees. So it has an extra condition. So square is a rhombus. Square is what is a rhombus. Why is that? Rhombus is very simple. It has minimum conditions to satisfy. But square, it has to satisfy more conditions. Also look at the diagonal part. The diagonal part also, square has one extra condition. Do you remember what it is? The diagonals of a square, three parts. They bisect perpendicularly, and there was one more thing. Do you remember? They have to be equal. So square is a rhombus whose diagonals are equal. Whose diagonals are equal and all angles are 90 degrees. That is the 2 point where square and rhombus differ. The sides part is same. Sides part is same. But the angles and the diagonals part is where the square and the rhombus differs. Now this brings us to the last type, which is a kite. It is a very interesting figure. You would have seen kites, no? In monsoon season, you can see all these boys, and now girls also. Now there is no such thing as boys and girls. Everyone does everything. But back in my days, the boys would all be in the roof of the house flying kites. And it's a very dangerous thing. You know, the string of the kite, it is made of such a strong material, it could actually cut people. So it's a very dangerous thing. But that is a real kite. This is a mathematical kite, which is a wonderful figure. Just look at it, you will know what I mean. this is a kite. In a kite, two adjacent sides are equal. So these two sides are equal and these two sides are equal, but these two not equal. That means suppose AD is 4, then AB will also be equal to 4. If DC is 6, BC will also be 6. That means it has one pair of adjacent equal sides and another pair of again adjacent equal sides. We go on to the diagonals of the kite. There are two diagonals of the kite and clearly you can see that one is longer than the other. Now this diagonal, the longer diagonal, is called the main diagonal and the smaller diagonal is called the cross diagonal. So the angles on the either side of the smaller diagonal are equal. So that means these two will be equal. Suppose one of them is say 120 degrees, then the other will also be 120 degrees. So the angles on the opposite sides of the smaller diagonal will be equal to each other. And also this longer diagonal, which is AC, bisects the smaller diagonal, which is BD. And how does it bisect it? Suppose this point is O. It cuts BD into two equal parts. So if BD is say 10, then OD is equal to OB is equal to 5. Not only does it cut it into two equal parts, it cuts it perpendicularly. All of these four angles formed are 90 degrees. So that is the properties of the angles of a kite. The two angles on the either side of the smaller diagonal, not the bigger diagonal, the smaller diagonal, the angles on both the sides will always be equal, and the main diagonal bisects the smaller diagonal into two equal parts and it divides it perpendicularly. It makes the angle 90 degrees. That is all the properties of the diagonal and the angle and the side. And here you can notice one interesting thing. Look at the smaller diagonal. The smaller diagonal, which is BD, which is called the cross diagonal, cuts the kite into two isosceles triangle. Do you remember what an isosceles triangle is? Isosceles triangle means two of its sides will be equal. So look at the smaller diagonal. They are saying that this diagonal cuts the kite into two triangles. See, one triangle up, one triangle down. And they are saying that these two are isosceles triangle. Is that true? We know that is true. Why is that? AD is equal to AB. So that is an isosceles triangle. BC is equal to BC. So that again is an isosceles triangle. So BD, the smaller diagonal, cuts the kite into two equal parts. What about the longer diagonal? The longer diagonal, or what we call the main diagonal, cuts the kite into two congruent triangles. Why is that? Consider this. Consider two different triangles. So this side equal to this side equal to this side, and this side is a common side. So there you have, it does not look right, but just imagine that, okay? Just imagine it to be one side to be small and the other side to be large. This is one triangle. My drawing is really bad, so please imagine that one side is small and the other side is large. This is exactly why I did not take biology in my school. My mother used to do all my practical work. God bless her. I was really bad at drawing. So now you see two congruent triangles. ACD, ABC, right? So AD and AB are equal. DC and BC are equal, and the third side is the common side. So you have two congruent triangles. That is the property of the diagonals, angles and the sides. Now let us quickly recap what we have studied so far. We started with a trapezium. Its one pair of opposite sides have to be equal. But then notice that the sides which are parallel need not be same. One side can be smaller than the other. All you need is that for them to be parallel. So trapezium is a quadrilateral whose just one pair of opposite sides is parallel. And what about a parallelogram? Not just one pair. Not just one pair. Both the pairs have to be parallel to each other, and with that we have a lot of other conditions also. The both pairs which are parallel should also be equal to each other, and then the diagonals should bisect each other, and the opposite angles should be equal. Any two adjacent sides, you take a parallelogram, any two sides which come near to each other, their sum should always be 180 degrees. So parallelogram is a quadrilateral whose both pairs of opposite sides are parallel. Then we came to a rectangle. A rectangle is a quadrilateral whose both pairs of opposite sides are equal and all angles are 90 degrees. But rectangle is also a parallelogram. Why is that? Look at the conditions they satisfy. Their both pairs of opposite sides are equal and parallel. But which condition does it not satisfy? That all angles are 90. So basically this much means it is a parallelogram. So it is a parallelogram with all angles 90. And what is a square? It is a quadrilateral whose all sides are equal, all angles are equal, all diagonals, there are only two diagonals are equal, and the diagonals bisect each other perpendicularly. Now square is what? Square is a parallelogram. And square is what? It is a rectangle as well. Why is that? Square is a parallelogram with its adjacent sides equal, all of its angles 90, and diagonals equal and perpendicular to each other. So where does it differ? In a parallelogram, the diagonals just have to bisect each other. They don't have to be equal. They don't have to be perpendicular to each other. They just have to bisect. Similarly, in the parallelogram, do the angles have to be 90? No. Any two angles just need to be, their sum needs to be 180. It does not have to be 90 plus 90. It can be 80 plus 100 or whatever. Its individual angles need not be 90. But then if it is a square, its individual angles are 90. Now square is also a rectangle. And where does it differ? See, the adjacent sides are equal. For a rectangle, only opposite sides need to be equal. But then when it is a square, the adjacent sides also have to be equal. So square is a rectangle whose adjacent sides are equal and diagonals are perpendicular. Does the diagonals of a rectangle have to be perpendicular? No. The diagonals satisfy two conditions. If it is a rectangle, they will bisect and they will be equal, but they do not have to be perpendicular. But then it is a square, so that is the extra condition you have here. So now with this we come to the end of this lesson, which is about the types of quadrilateral. Till I meet you next time, stay safe. Assalamu alaikum.